factory. Welcome to my messy workbench and whatnot. You know, I had a fella that I was helping, via FaceTime to fix his SDR1000 reverb. And get the gear on here. And he also decided that since we got his unit fixed, that he would mail me this. A Roland R-70 Human Rhythm Composer. So, what this thing does, well, I got to get the power supply for it first. So, hold that pose. Let me find the power supply. What the heck it was in the box. Well, that's interesting. I don't know what I did with... Well, that's what I get for frantically unboxing something. Roland adapter. This, however, is it's a replacement one that the owner picked up. But I got to get it plugged in here, and we need to check it for functionality. So I guess first thing I'll do is just put the meter on it here and see what we got. Okay. It says 12.4 volts. It says DC output 9.5 volts. Okay. It's pretty heavy, so I think maybe it is a I guess I should get you over here so you can kind of see what I'm doing. You know, a non-switch mode power supply. So it's just a transformer and diodes. Okay, let's look at the AC ripple here. Oh, geez. It's got almost zero ripple, which it should if it's no load. So apparently the capacitor is okay and the power supply is okay. Yeah, we'll start doing some testing here. I got to kind of get things set up. I'll be right back. Away we go. So, let's see. I need something to put stuff in. Let's just grab a little lid here. Okay. Oh man, I'm just dropping stuff on the floor. Okay, back at it. Well, I had to get some more solder wick, so things were delayed a little bit. That screw is stripped right there. The middle one, I'll have to see about, maybe I can melt some plastic in there with the solder gun or something and fix it up. At least make it tight enough to hold the screw in. Alrighty. Looks like well, I got to do a bunch of disassembly work here. So I'll of course, you know what? Before we even get started, there's a capacitor in here that is bloated. So What's the value on that thing? 10 microfarads at 16 volts. Boy, they're all little short guys too. So, oh man. Pretty much there's only two sizes in here. There's 47 at 16 volts, and isn't that what that is? 47 microfarads at 16 volts. 10 microfarads at 16 volts. And this is over in the... is this the power supply? Yeah, this is the power supply. Okay. I guess it's not worth going any further. I have exploded caps and I need to order them. So that's what I'll do. I think I'll order maybe, just looking at the population of them there. I don't know how much they cost, but it's usually pennies. I'll order like 20 of each, and then I'll come back and get to this. Okay. Really no point in going any further. What this thing does is let's put that, okay. What it does is when you turn it on, it just says serial error and it won't do anything. So I called the customer and he said that sometimes it would actually work, but it wouldn't work very long. Okay, well, I guess that was a good start. Hi, welcome back to Don's Manufactory. Well, the capacitors came in. So no, I got lazy. I just was so excited to dig into this thing to see if I could get it fixed for the guy. And messing around with this thing, I made the realization that there are capacitors here that when you touch, there's some kind of leakage. I can measure voltage on the aluminum housing, and they're all sitting on a 5-volt rail of some sort, but some of them have voltage on the aluminum part and some of them don't. But if I put my fingers right here on these two caps, I can change the operational mode of the drum machine. I mean, it still doesn't work, but I can like step it through modes, which you can't do from the front panel. So I'm thinking I'm just going to replace all of these, this fat one here and all of these, and then I'll bring you back when I've got that done. At this point, I have replaced all of these little caps. Let me find that bloated one for you. Where in the heck is it here? That's not a that's not the bloated one. I just dropped these on the floor and then I was picking them up. Oh, here it is. So this little tiny cap here, it's just the top, instead of being flat, is domed. It doesn't, nothing came out of the bottom of the thing, but let's see, you can see that, I hope. So it's saying 0.7 nanofarads for that one. Geez. I just replaced 1, 2, 3, 4 of them. So there's, I just tested 2 and there must be 2 more on the floor somewhere. Well, you're just going to have to jolly well take my word for it. So a couple of them tested bad, but I decided to replace this whole line of them right here. These are all 47s and 10s, at 16 volts. And then, of course, I replaced this one here. And I think this one right here, C45, this filter cap sits between the positive rail on this side and the negative rail on that side. And it was decidedly bad. So if I were to guess, I'd say that puffy one was what was making things not work. But these were obviously not working either, because now I show two of them, of those little 10 microfarads that were bad. Unfortunately, to test this thing, I have to put it back together. So let me do that. So this side goes down, and then it's got to go, I got to get it inside the back, but I have to make sure the power switch goes in. There it goes. And then before I tighten it up, I have to, well, I was getting ahead of myself there. I need to tip that up. See, I got to get these harnesses plugged back in. That one there. That one there. That one there, yeah. Gotta make sure that I can't put them in the wrong hole here. Okay. And I gotta plug the harness into the faders. Now, I took the fader control out. I was looking at the schematic for this thing, and there's a bunch of revisions that need to be done. And so I was checking to see if all the revisions have been done on it, like these here, where the traces are cut and the jumper wires are put in. Another one was trimming this shielding foil away from the potentiometers, because there's a possibility of it shorting out. And then I discovered one that's not on the list. And, well, get that up there where it belongs. Let me get it kind of in place here, and then I'll show you what I mean. Come on. There it goes. It's not quite there. What don't I have in place here? There we go. Well, the screw holes are still not lining up. What am I doing wrong here? Oh, I see. There it goes. I was just having trouble getting this drive thing put into the slot. Okay, now the screw holes line up. Okay, so here's the thing I figured out. And I just went ahead and did it. There's a little not carbide, but it's an inductor tube. It's just acting as a choke on these wires that go up here to the communication and audio lines. And the whole idea is to stop the high frequency digital racket from getting into the audio circuits. Well, this thing is wire tied up here, but it is so close it can touch the circuit board. It just barely clears. And I was thinking, with it bouncing around, that thing could short against the board here and blow those capacitors that I'm messing with, or even the regulators for the power supply. Anyway, so you can see I just put some gaff tape on it and just I taped it up so it was a little tighter to the board, but it also provides a little insulation there so that it won't short. And I guess I'll have to be honest with you here. I screwed up. Which, oh gosh, you know, sometimes I'm just clumsy. But I was testing stuff with my scope. And let me grab my probe here. So I was using my probe, and I had both probes on the board, and I was doing some testing. And this one here, I had a jumper wire on it, or it's actually this one here. See, let me grab the other one. This is the one that had the jumper wire on it, and you can see now I have a piece of tape on there. Yeah, that's because I let that drop down, and it shorted the power input jack, the power supply jack, and it blew. It blew this little 5 amp fuse inside the power supply. So, yeah, I gotta come clean. I gotta come clean here. Come on. Boy, I am just a tangled mess here. Okay. So, I ended up cutting this power supply open so I could open it up and replace that fuse. And then I've just got it held together here with gaff tape again, because who knows, maybe I'll short it again and I'll have to replace it again. Idiot. Sometimes I'm just too clumsy for my own good. Okay, let's get a few screws in here. Don't want to tighten any of these. I just want to get a couple of screws in the back here, get it held in place. Okay, like that. And then leave those loose while I put all the screws in the back panel here. Let me flip you around here so you can see a little better. So we got these little guys here, and these two screws have a star washer on it, and I'm assuming that's just to get the, yeah, come on, let's get that where it belongs here. There it goes. Boy, my phone is just dinging off the hook. Okay, another one with the star washer goes right here. And then the rest of these, I'm just going to go ahead and tighten those. So what I'm doing here is I didn't put all the screws in the board, because I know when I tighten these across the back, it's going to slide the board forward. And I don't want to put tension on all the solder joints for all the jacks and everything. So I want to get all this put together before I screw the board down. The whole idea is to make sure it lives long enough. Eller Beller's stopping by? Cool. There we go. And let's see, there's one more thing. Oh yeah, this little takes a longer screw for this little cord wrap or whatever the heck this little thing is. So I will loosen them all back up. Did I just break my own rule? Don't tighten anything until all the screws are in.
Hi, Grandpa.
Hi, Alpa. That screwdriver is not serving me well. Let's use this one. There we go.
Hey, how's it?
Yes.
Are you posting this?
Meet Elpa, my granddaughter, and friend. That is real.
Speaking of cars, and you mechanic, sir.
Mechanicin. Yeah.
My car's making a really strange noise, and we should check it out sometime soon. Yeah.
Well,
Yeah.
here. Did you hear that? Yeah. This goes with the territory. Okay, so cut. Back to assembly. Just a slight distraction there. I gotta get these cables plugged in. Over here, they just push in, pull out and push in. Come on. There it goes. Just like that. Okay. Everything is tight. So I think that's everything, right? I can just pop the bottom back on, flip it over, and let's see how it works. We'll just put a few screws in here. Flip it over. See if it's good. So, let's see, power supply. Alrighty, so turn it on. And it works. It doesn't say serial error. Okay. I'll see if I can make this work. I got some headphones here. Get them untangled. Good grief. Okay. Sorry about that. Kabunk. Okay, so phones right there. So contrast control works. Yep. That really looks good. So, if I hold the, let me just do this. I'm going to put these right here. And let's play a pattern. Is it playing? Yes. I'm just running up through the patterns if you want to know. Alrighty. Tempo 120. Oh, let's slow it down. 104. Oops, I messed up. Well, I'd say that's a success. Let's call it good. So, during the interim of waiting for parts for this one, I had another unit come in. So let's grab that one. And I'll show you how far I got on it. And yes, I know I was supposed to film the whole thing, to make you happy, but I didn't. You'll just have to bear with me. I'm just not always feeling up to it. Here is the next device. It is a... Well, let me get a little more height on this. You can see it is a Yamaha SPX90. So, symptoms. Display worked, no audio. I already got the screws out of this because, yeah, I know, I've already been working on it. Because, that's just who I am. Problem was these capacitors are bad. Look at this one. See all the crud that was coming out of it? And it eroded this stuff that comes out of these capacitors. Let me lower you back down here. There. The stuff that's coming out of these capacitors is just eating away at the terminals and stuff. See this stuff here? It was adhesive, but it's turning caustic too, just like it is over here. So I got to clean all that up. This one right here, I had to pull it out and clean it all up and clean the legs and then solder it back in because the junk that came out of the capacitor ate the solder until it was just a gray powder and it wasn't even holding the component in anymore. Okay, so what I need to do is replace all of these. This is a cap I had in stock, so I put that one in, and I had one of these. It's taller than the original, but here, let me just get you over here. Okay, so you can see, just look at how cruddy this capacitor is. See how it's all crumply on the outside, spitting gunk out the bottom, and how bulged it is on the top? Yeah, it was pretty obvious. Unfortunately, I don't have the rest of these values, so these four I have to order so that I can replace them. So while it is actually working now, I can get audio through it. These 80s and 90s units have relays. One is for bypass, the other one is a mute. So anytime that the RAM, you're changing settings or something and the RAM is full of garbage, this mutes the outputs, and then as soon as a period of time has gone by and it knows the RAM is clear, then the relay will close again and allow audio to get out of the outputs. It also won't close the outputs if the power supply is unstable, which is the situation we have here. So as soon as I replaced these two caps, the unit started working. The relay closed. In fact, I could plug it in here and show you. Excuse me. Power is right here. See, and we have, see, program 1, warning, low battery. Oh yeah, that was the other thing. This battery is one, I got to order one, a 2032 with tabs. I got to solder a new one of those in. I cleaned this pot because it was real scratchy. But now, if we watch these relays, see? Then it closes, see? So that period of time has to expire before that relay will close. So if the power supply is unstable, then that relay won't close and you'll get no output out of the audio jacks. So it's another ordering parts and waiting a week for parts before I can finish up on this one. But it'll be a fully functional unit when I'm done. So that's it for this episode. Whatever. Anyway, video is over. Time cut. Whatever. I'll catch you guys on the next one. Catch you later.